Hi, I'm so excited to hang out with you and talk about containers and DevOps. How's everyone's DevOps Days Mana video, the first one ever? How's it going for everyone? All right. Well, we'll deal with that. I made you scream already. So today, we only have about 45 minutes, but what I hope to do is add some clarity in containers for you. And by the way, before I get started about containers, I have to laugh at just the safety of this right here. I see a giant thing of water in my computer. I'm like, I can't move at all. This is dangerous. Just out of curiosity, how many people in the room are already using containers? Okay. How many people are already using Kubernetes? How many people are already using Helm? Okay. So we're going to take the slow road because only about half of you are even familiar with containers. 25% of you are familiar with Kubernetes, and then like 10% is familiar with Helm, which is an awesome package manager and will simplify your life with Kubernetes. But we're going to start slow. So I want to make sure that we have a disclaimer, because in a short amount of time, it's really impossible for me to teach you absolutely everything. Despite what the title says, I can't make anyone a superhero. It's kind of sad. I also can't do any of that in 45 minutes. But what I can do is I lost my monitor. But what I can do is get you excited. I can hopefully show you some things to get you thinking, maybe get you thinking about what you're already doing in your own processes, in your own development work, maybe get you, again, excited about what's possible. And then at the very end, I have a present for you. Well, there will be resources where you can go and learn more. Now, I don't think it comes as a surprise to anyone that technology is changing, right? It's changing at a rapid pace. Technology, even 5 years ago, was drastically different. 10 years ago was a 180, and 20 years ago, it's almost unrecognizable. And I love this particular quote by Monty C.M. Metzger, because I think it really sums up, from a financial perspective, which from a business perspective is what really makes the decision, just how technology has changed. Uber, the world's largest taxi company, owns no vehicles. Facebook, the world's most popular media owner, creates no content. Alibaba, the most valuable retailer, has zero inventory. And Airbnb, the world's largest accommodation provider, owns no real estate. Welcome to the digital economy. Welcome to where all the businesses actually own nothing. How amazing is it that this is the state that we're in? But as a result, if you also think about all of these companies up there, Uber, Alibaba, Facebook, they've all been around for 10 years maybe. They're all fairly new. They're not the staple blue chip, Coca-Cola, Johnson & Johnson. They're newer companies that are doing things that are disruptive, that are transformative. And so for us as engineers, be it developers or operations, how do we scale with this? How do we transform? How do we grow? And how do we reassess our, for lack of a better word, how many people watch Agents of S.H.I.E.L.D. or superheroes or are familiar with it? A handful. Okay, awesome. I knew it. There's quite a lot of geeks in the room. I love it. So pterogenesis, right, where I go through my blossoming and I'm going to become a superhero. Obviously, with a superhero talk, we're going to have a lot of superhero things. But how, as engineers, do we go through our pterogenesis, our change to become that superhero? I believe that it's going to start with DevOps and then containers. And so just as a refresher, Donovan Brown and I talked yesterday about what DevOps is. And remember that DevOps, from our definition, from Microsoft's definition and our team, is DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. We talked about how the most important word in that definition and on that slide is value. If you're not delivering value, what are you doing and why are you doing it? And then more importantly, how do you know if you're delivering value? How can you gauge it? For those of you that are using containers or Kubernetes, if you're using it in production, do you have insight and metrics and telemetry? Something maybe a little bit easier than Prometheus or Grafana? Something that helps you monitor what you're actually doing and where things are running. I talk to enterprises all the time. I'm using containers in Kubernetes. I don't actually know what that means, but I don't know where it's running, but we're using it. That's not exactly a scalable solution if we're going to talk about this kind of growth. And that's where DevOps really comes in. If we want to be high performing, which is another definition we talked about in our keynote, we really want to set ourselves up for success. So that's where containers comes in. But why? Because I think a lot of people, they hear buzzwords, containers, Kubernetes, go to that conference, buzzwords, I like that. But that doesn't actually explain why we care about it. Why is it central to DevOps? How many people in the room would identify themselves as a developer or a systems engineer? Software developer, cool. How many people would identify themselves as maybe an operations engineer on the ops side of things? Great, we have a healthy balance. Now, how many people would just do wear whatever hat their boss tells them to wear? Everyone's hand should go up because we all should be listening to our boss. Otherwise, we need to have a conversation. But for the developers in the room, we all know the age-old saying of, it works on my machine. Give me a hammer, give me a floppy disk, give me a zip disk. I'm going to go in, I'm going to touch your servers, and I'm going to fix it. But the ops person is like, no, no, no. I have security. I need to keep the lights on. I need to keep it up. So when we have containers, it's really central to the concept of DevOps because it enables and sets us up for success. It enables this write once, run anywhere architecture. It really sets the foundation for microservice architecture. And for an ops perspective, it gives us portability. It gives us abstraction. It gives us standardization. Long are the days, or long gone are the days where we're wondering why it doesn't work on dev and it worked in test, or why it doesn't work on prod, but it went through all of the other virtual machines and worked everywhere else. Oh, the version of Java got updated manually somehow. Now we have things that are standardized. I have abstraction with containers. I have higher compute density. And most importantly, I have the ability to scale. And I can scale small or I can scale big, depending on how I need to. But for those of you in the room that raised your hand that said you're not using containers, or maybe who were affected by Thanos from Marvel Endgame, from Thanos' snap and disappeared for 5 years, what's a container? What's actually going on? First off, I love telling people it's not a real thing. Doesn't actually exist. We're just talking in words. But what a container actually is an application delivery mechanism with process isolation. Now, unless you actually stop to think about that, it's like, okay, yep, that sounds good. What does that actually mean? First off, a lot of the process features and the way that containers work was based on Linux kernel features. So if you come from a Windows background, certain concepts are going to be new, right? You have things like C groups and namespaces. But what do those mean? Those are really just what a process can see and what a process can use. And so that's what you start to define in your Docker containers, in your Kubernetes manifest files. You start to define what the process that you're actually running is using and what they're allowed to see. So let's make sure we also understand what containers are not. First off, they are not virtual machines. They're not little portable virtual machines that are just running around everywhere. Remember, it's not actually a real thing. It's not something that I can put into words other than it's just something that's an encapsulated runtime. There's no hardware virtualization involved. There's no virtualization involved whatsoever. And as a result, there's no hard security boundaries at all. So that means in my container, I can, if I don't have the right security policies in place, jump out of that container into the host. So that's where we're going to also talk about layers and how it works. Now, I love telling people my definition of a container, where I said that I can't actually put it into words. It's a waffle. Or a pancake. I'm not sure if waffles are very popular here, but they are in the United States. Now, question, how many of you like to eat waffles completely plain? No syrup, no toppings, no fun. Okay, good. We don't have, one person. There's always one crazy person in the room. Always one. So I tell people it's a waffle because this is boring, right? I'm not delivering any happiness or value to my body. But if I add all the toppings of strawberries and blueberries and syrup and whipped cream, now that waffle becomes a delivery system for happiness to my stomach or all of your stomachs. So at its core, if you think about it, it's just a waffle, is what I tell people. But that's important because we want to make sure that we don't overcomplicate the point of containers or what a container actually is. I love this particular graph because it really shows the differences between virtualization and containerization. So remember with virtualization, you have either a host OS and your hypervisor sitting on top of that. Maybe that's Hyper-V in Windows Server. Or you have your hypervisor sitting directly on top of your infrastructure. That might be VMware, ESX, ESXi. And then on top of that is where you actually have your virtual machine. That's going to have your guest operating system, your dependencies, and your applications. And each virtual machine is going to be different from the other virtual machine. But in containers, instead you have a host operating system, and you have a Docker engine sitting on top of that. Even if you're using Kubernetes, the Docker engine is still that underlining container runtime that's enabling your containers and your pods to work. And within your container is where that's that delivery mechanism, that process isolation. I now have my entire runtime encapsulated into a container that's only using what I need, my application and any library files or dependencies that I define. That's all a container is. Now let's talk about container layers, because I can't tell you how many businesses I've gone to where they're, as part of their container, as part of their definition, they're passing some sort of secure information. An SSH key, a personal access token. One person was doing a git clone from a private registry and was passing in their private admin SSH key into one of the layers and baked it in and published it in production. I'm like, they didn't realize, they're like, oh, well, the layer is, I don't know, 5 lines back. It's still in your container. Because layers at the end of the day are like a cake. There's a lot of food references in this. But hopefully it helps really kind of visualize, right? Anything I define in my Docker file, the world's easiest Docker file, from scratch, and then the next line is run, I don't know, echo hi, right? That's the easiest thing, but that's still 2 lines. That's still 2 layers. So it's important to remember what's actually happening in your image layers for your read-only. And your writes are actually happening at the top. So anything you have baked into your cake, I can go access. Even if I have blueberries down at the bottom, and I thought I got rid of those blueberries, I can still go back and grab them. And blueberries are just another way of saying SSH keys and personal access tokens, or security and passwords. Now, another common question that I get asked a lot is, if I'm not using containers, am I behind? Is it too late to learn? The answer is no. Now is the best time to move to containers. Containers have been around for a long time, yes. Kubernetes has been around for about 5 years. Google's been doing containers with what Kubernetes was based on, called Borg, for over 10 years now. But at the same time, it's still not too late, because Kubernetes isn't going to be the thing. It's just the thing that's going to get us to the next thing. If you think back to 15, 20 years ago, no one thought anything was going to come after virtual machines. And now we have operating system virtualization with containers. We virtualize the kernel. So now truly is the best time. If you don't do it now, you might be too late in the future. You might have missed the boat. It is more cost-effective, efficient, and reliable when you run things in a container. Because now, again, I'm taking that process isolation, I can distribute it across a series of servers, rather than having 5 or 10 dedicated servers for each project or each application. And as a result, from an ops side of things, I now have dramatic deployment and resilience benefits that I previously didn't have. So for the developers in the room and operations in the room, containers give both of you an advantage, right? It'll give you the ability to quickly iterate, to have an agile delivery plan, and to have something that's immutable, so it leaves my system as a developer and it still works in whatever environment ops decides to put it on, which gives cost savings, both from a actual human resource perspective, not having to sit there and spend so many hours, but also from a server perspective, because now I can take greater control over my actual infrastructure. We already talked about efficient deployment, but I also can utilize things like elastic bursting. Maybe I'm doing more of a hybrid situation and I want to go from on-prem into the public cloud. I can do that with containers. Now, the other thing that I think happens a lot is people tend to associate containers with just Kubernetes, as though nothing else happened before then. It's not true. In fact, I would argue that a lot of times people use Kubernetes, they don't know why, and they don't know that other solutions exist. So from Azure's perspective and Microsoft's perspective, we actually start small, especially for those of you that are looking to get into Docker, Kubernetes, trying to get into containers itself. Perhaps the easiest place to start is with the Docker run version of the cloud, which is what we call Azure Container Instances. On the back end is Kubernetes, but you don't see any of that. You don't have to worry about dealing with servers or clusters or anything. It's just one command and you can run your application. As a result, we tend to call it containers on demand. It's per second billing, so you're not having to pay for large infrastructure. You can integrate seamlessly with other Azure services. I did a blog post, I think a few months back, where I took a Ghost blog, put it in a Docker container, and then linked it over with Azure Storage for my images and Azure Database as a service for my actual backend, and ran that as a container instance rather than running it in a web app or something else. It was a lot faster for me to get up and running. And as a result, there's also no need to provision virtual machines or clusters. The overhead is a lot quicker. You get hyper-level isolation. I think this one's one of the big ones, because if you are using Kubernetes, you now have to account for additional security. We talked about how easy it is for you, if you don't have the right policies, to jump out of your container into the host. Azure Container Instances gives you an additional level of isolation that you don't have with other solutions. Give you a public IP. You can also set your own DNS, persistent storage, and the neat thing is it supports both Linux and Windows containers. Just out of curiosity, how many people have tried playing with Windows containers in Kubernetes? Okay, like 2 people that probably were hitting their head. The differences between Kubernetes on Windows and Kubernetes on Linux are extreme in the sense that you have to care about the kernel. If I want to build an Alpine image on Debian, no problem. Or RHEL, for that matter, no problem. But in Windows, I have to care about the kernel version. I can't build a 2019 image as my base image for my Docker file on a 2016 server. I need to make sure the kernel versions match. So Azure Container Instances simplifies a lot of those specific things very easily. When I say it's super simple to get started, it's one command. And all the command is doing is saying create a container, put it in a resource group, give it this name, here's the image, here's my DNS, and the port. It's all very standard kind of definition. Now, AZ is our CLI. That's our cross-platform. It runs on Linux, Mac, and Windows. I can even script that. I have really robust pipelines that we don't have tasks for, or the tasks I haven't written yet. So as a result, I just use Azure Command Line as part of bash tasks in my pipelines to run anything I need for infrastructure provisioning or pulling down secrets or information accordingly. Azure Command Line is really powerful with that. But you'll start to notice a theme as we go on as far as how simple it is. In this instance, I want to create a container. Now, the next instance is Azure App Service, and I can do Azure App Service for Linux. It's a fully managed platform as a service for containers. It supports a wide variety of different workflows. It's just like your standard app service, but you're running a container. I can run it from AZACR. I can pull an image from AZACR, which is Azure Container Registry, Docker Hub, or any external registry. It supports even advanced features for web apps, like things like deployment slots. So on a web app, I can say I want dev and QA and prod for my deployment slots, and I can allocate traffic accordingly. And I can control that traffic as part of my pipeline with Azure Command Line. And what the traffic routing does is now that allows me to set up things like canary, blue-green deployments, A/B testing. I can set up different deployment strategies that are based on DevOps and still take advantage of container infrastructure. To get started with app services, just like container instances, still very simple. AZ Web App Create. What did I want to do with ACI? AZ Container Create. You're going to start learning how it's just very, very simple. Now, the next one, of course, which is probably what everyone's interested in, is Kubernetes itself. But before I get into Azure Kubernetes Service, I want to make sure we talk about what exactly Kubernetes is. So it is, at its core, an open source container orchestrator. Now, you might wonder, what's a container orchestrator? There are key features that container orchestrators have. Things like scheduling, planning, service discovery, load balancing, self-healing, the ability to essentially facilitate where your containers are going. Prior to Kubernetes, standard ones were Docker Swarm and Mesosphere, DCOS. Those were 2 popular ones. And then Google released Kubernetes. It was actually designed intentionally to automate deployment, scaling, and management of your applications. It was built on something that they've used for over a decade called Borg, and they've been doing it to run billions of containers per week. Containers have been around for a very, very long time. Now, to make sure we understand fully how container orchestration works, to make sure I haven't made anyone go to sleep, I'm going to show you a quick video here. Now, this video was filmed at KubeCon about 2 years ago, and it started out as a joke for an education training, and now it's kind of gotten around and people seem to love it. So we're going to make sure that we try to explain container orchestration with little puffy things that you can throw. It's a spoiler alert. Oh, wait, hold on. Just realized I need sound real quick. Otherwise, it wouldn't be as funny. And this is where it gets I have to be very, very careful. And look at that, live DevOps on stage, human interaction. Oops. Oops. Hi, my name is Jessica Deen, and I'm a cloud developer advocate at Microsoft here at KubeCon.
And I am Eric St. Martin. I am also a cloud developer advocate at Microsoft, but I am not at KubeCon.
Then how are you right next to me?
You're not at KubeCon either.
What?
We've got green screen and an amazing producer.
This is some really good virtualization.
So
what are we doing today?
we are going to do a live demonstration of container orchestration with something like Kubernetes.
I'm really excited. Let's get started.
Over here, we have our image repository filled with containers that we would like to deploy. Jessica is going to be our scheduler.
Apparently.
So here's our first container, and go. Bad Docker file.
You can laugh.
Okay, we fixed the Docker file, and we're going to deploy this one.
Yay!
Sweet.
And we can have multiple schedulers,
So-
especially for the sake of time.
There we go. Containers, lots of containers.
So let's make sure that we also get our bin packing in order here.
We don't want any leftover memory.
Nope. Gotta be efficient. Always efficient. Look at all these apps we're deploying. This is gonna be the best node ever. I'm so excited for this node. Look at this. It's so pretty. I can't wait to see this node done. It's gonna be my favorite node
Here comes the
ever.
IT guy.
Best one. Hey, Zach.
What's up,
Facilities,
man?
maintenance.
What are you guys doing?
We're talking about container orchestration.
Yeah, we just deployed a node on the server.
Right,
We just
I
deployed
mean,
a bunch of apps.
I mean, really neat. Do you mind if I wait?
Well, actually,
Ah,
now we have node failure. What are we gonna do?
I don't know.
we actually have a Kubernetes cluster.
That's right.
So, want to see what happens when?
Yeah, so let's go over to our other node. Look at that, thanks to Kubernetes, we've taken all of our failed containers and now we migrated them over to this awesome second
joys
node.
of camera angles.
This is fantastic.
It's magic.
I really hope that this helps explain how orchestration works. Thanks for watching social media.
So a funny story about that video real quick is I sent that to my aunt who lives in Florida. And she's older. She doesn't understand really what I do in technology, never has. Her definition of sending a text message is send me a bubble. So that really explains where she's at. But I sent her that video and she's like, oh, I get it. It means if it's broken, it's not really broken. There we go. So that's container orchestration, right? At a high level and funny level. But I want to make sure we understand the technical details of it. So Kubernetes has what's called a reconciliation loop. That's how the scheduler is always making sure that the pods are running, going to the right nodes, and doing the things that you want them to do. So you have something called the desired state. That's your declarative syntax. That's your manifest files where you define out everything that you want for your deployments, your services, config maps, ingresses, anything you can think of, that's your desired state. But then your actual state is what's actually happening on your cluster. And the scheduler is going to constantly be monitoring that and look at trying to reconcile that. And that's that reconciliation loop. So here's a good way to visualize that. And I'm going to make sure I stand off to the side. Stand off to the side over here so everyone can see this angle. So you have what's called your manifest file or your YAML file, which is your deployment over here in this example. And that's deploying out an Nginx deployment. Kubernetes is right there in the center. We can see that we have spec and replicas as two replicas that I want to define. Here's my template, and here's my container. That's why I have a second spec for here's the containers I'm deploying. But what happens if I weren't deploying a public image like Nginx? What if I were deploying something private? Now I have to account for image pull secrets if I'm using just the standard practice. If I were using Azure Kubernetes Service, I could use a service principal or managed identity. But now I'm going to have to go in and manually edit this and hard code it. And each change, I'm going to also have to hard code. So we'll talk a little bit about that. But essentially, I take this definition, I deploy it somehow, either kubectl apply, kubectl create, however, give it to Kubernetes. The Kubernetes scheduler is then going to say, oh, you want two replicas. You didn't tell me where to put them, so I'm just going to put them here. And it puts it on the worker nodes. Now, let's talk about how that actually looks. So on the right here, you have your master nodes. That has your etcd for your database, your API server for Kubernetes. And you also have a controller and a scheduler. As we talked about in the video, you can have multiple schedulers. And that's what's actually moving and putting the containers over on the left, which are your workers and your nodes. And each one of those workers and nodes have a little kubelet and a kube proxy and has your container runtime where your pods are actually running. But this instance is technically a visual of an unmanaged instance of Kubernetes. Unmanaged, you're responsible for both the control plane, those are those master VMs with your scheduler and your etcd and everything, and you're responsible for the agent pool, which is where your pods and everything are actually running. That means it's going to be very hard for you to do Kubernetes upgrades. You're hard to do any kind of canonical upgrades, software upgrades. You're responsible for a lot more that gets a lot more complex and a lot more challenging. So when they tell you, and I say they, any cloud provider, Oracle, Microsoft, Amazon, Google, you name it, when they say it's managed Kubernetes, this is what it actually means. It usually means that the control plane is taken care of, and all you have to worry about is the worker pool or the agent pool. Now, from Microsoft's perspective, I don't work for anyone else, so I can't comment officially, but because we take care of the hosted control plane, we don't bill you for it. So it's free, and you don't have to worry about it. We back up by our SLAs, and it's something that we manage. So that scheduler that also got mad at the Docker file, I mean, I can't help you rewrite a Docker file, but I can tell you the scheduler is going to work. It's going to be the one it's going to be backed by our same virtual machine SLAs. Now let's talk about AKS itself. Because sometimes people hear Azure Kubernetes Service, and they're like, oh, that's Azure's version of Kubernetes, right? No. It is 100% upstream Kubernetes. So it's the same Kubernetes you would run anywhere else. But we give you, because of the master and hosted control plane, we give you automated provisioning, upgrades, and patches. So we take care of a lot of the pains for you. We give you high reliability and availability. Of course, availability is really dependent on your definition. I would argue that to truly have a full high availability cluster, you would need multi-cloud and multi-region. But again, take it as you will. But we give you high reliability. And we give you easy, secure cluster scaling. We'll talk about scaling. It's self-healing, that's that control plane. So if the control plane does go down, we'll back it and spin it back up. It'll self-heal itself. API server monitoring, and all of that at no charge. And remember, the APIs are part of the master control plane. So not only do we have Azure Monitor, but we also have tools in place to monitor your clusters as well from a hosted control plane perspective. And so that's the Azure Managed Control Plane up there in the right-hand corner. You have your user that defines out the workload, that declarative syntax, the way you want the world, either from Helm charts or a Kubernetes manifest file. And then it actually schedules pods over a private tunnel over into your Kubernetes cluster. And outside of the pods, remember, Docker's kind of that engine that's running beneath it. To get started with AKS, again, still very simple. And now you'll notice how the commands we talked about in the beginning, AZ container create or web app create, looks very similar to AZ AKS create. It's the top command. To create, specify a resource group, name of cluster. This instance is generating SSH keys for you, or you can use -I, which will provide your own. The second command is technically optional. If you already have kube control or kubectl, there's a whole debate on Reddit about this, about your pronunciation for that, but if you already have that installed on your system, you don't have to run that second command, because that's just going to install the binary to interact with your cluster. The third command is going to set up your credentials. That's what's going to actually set up your system, your build system or dev system to talk to Kubernetes. And then the final command is showing how that works. I use the binary, I say get nodes, and there are my worker nodes, which by default, if I run the first command and I don't specify it, I get 3 worker nodes. Beautiful. Now, the next page is how easy it is to manage AKS. Since we do a lot of things for you, you can interact with it with Azure Command Line. So you do AZ AKS list. That'll give me a list of all of my clusters. I recommend doing -O for the output being table, unless you very much like reading JSON for some reason. But I like putting table at the end of everything. If I want to upgrade to a different Kubernetes version, I just do AZ AKS upgrade. And then I do get nodes, and I can see the version that I'm currently running on. And then the final command for managing would also be AZACR scale. And that's where I can scale the agent count. I could also choose to scale for a node pool, and we're going to talk about that. Because AKS scaling gets a little bit tricky. Not tricky in a bad way. It gets tricky because we actually released about 2 years ago something called Virtual Kubelet, and about a year ago, we then open sourced it and donated it to the Cloud Native Cloud Foundation. You can use Virtual Kubelet in your cluster as a virtual node. And that helps you, particularly because when you're saying, okay, I want it to go to this node pool with my virtual node, now I can take advantage of Azure container instances. Now I don't have to have 20 or 50 different agent pools if I don't need it, or agents in my agent pool. The secret to scaling is virtual nodes. I can take greater advantage. So I can use Azure Monitor to monitor my production cluster that has all of my little microservices on it with my availability, reliability, but I can also set auto-scaling on those deployments that'll connect to the virtual node that I deploy in my cluster, and then it'll run out and deploy out to Azure Container Instances. It's a serverless way of handling Kubernetes, and the best part is, because we donated it to CNCF, it works with other cloud providers. You don't have to use Azure to take advantage of the virtual node, or virtual kubelet rather. Now, the last thing I really want to talk about, and then I promise you I'll get into a demo, but is Azure Container Registry. It's a private, highly available container registry where I'm going to put my Docker images. I can manage images for all types of containers, all types of clouds. Don't have to only use it with Azure. And then I can also manage that single registry across multiple regions. So it's available anywhere. I can put my registry in different regions. And as a result, I can interact with it the same way I would any other registry, meaning I can use standard open source Docker CLI tools. What I mean by that is this. The first command is AZACR create. Noticing a pattern, every type of service I want, I just use create. Specify a resource group, the name of my container registry, and the SKU. The SKU is different settings that I want, if I want premium or basic, high availability, redundancy, replication, all of those things. And then the next command is AZACR login. That's going to actually log into my container registry so that I can begin to push images to it. The next two commands are standard Docker commands. I would run them with any container registry whatsoever. So I do Docker build, period for my Docker context, tag, and then I tag it with my container registry name and image name. And I push it the same way. And that's it. So I can interact with it just the same. But we also introduced something called build tasks. So now I can take advantage of building my containers in Azure Container Registry, which gives me a lot of leverage, especially if I'm working from Windows system. I don't have to build it locally in Linux. I can actually take advantage of ACR to build it. And ACR is actually going to reach out to Azure Container Instances to spin up a little builder and run that build for you in Azure. So to do that, again, it's very simple. You just do AZACR build task. And then I do create. I specify the various parameters, the image name, the name itself for my build task, registry, context, even if I want to do external context, the branch, and my get access token. Now you'll notice, I think it was on the last slide, I said something right down here at the bottom that I can also do trigger-based builds. So anytime I do a git commit, I can trigger and have it rebuild that image in ACR, so I don't actually need to have Docker build on my local server. And I can also take advantage of base image updates. So I can set a task that once I've changed the base image, anywhere where that image is used, automatically go and rebuild those Docker files. So it gives me a lot of strength and flexibility as far as scale. Now, also, a lot of people don't know, Azure Container Registry supports Helm charts. So for those of you in the room that raise your hand if you're using Helm, I don't know if you have your own private Helm repository set up. It's still very new into adoption. You treat Helm repositories the same way you would Docker repositories. It's just a place to store your definition for deploying an application. So, and I can override any of those definitions with certain variables. Helm is a package manager for Kubernetes. It is the de facto package manager, meaning it's the overall universal package manager. And it runs on a template engine. So rather than hard coding everything that I showed you earlier for Nginx, I can actually use parameters and variables to parse in my various deployments. And rather than managing 5 or 6 different YAML files, I manage one. In fact, I'm doing a deep dive into Helm and how to get started with Helm and how to understand it at a meetup later tonight. So if you want to come check it out, come talk to me. I'll give you the information. But AZACR natively supports Helm chart repositories. And it's, again, super simple to set up. This I set up because I like using variables. So the first line is setting a name for my AZACR. And then the next lines is just going to use that variable. I do AZ configure. I give it the name of my container registry. And then I do AZ AZACR Helm push. I don't have to set up anything separate for my container registry. It's automatically set up to work with Helm. And then I do AZ AZACR Helm repo add. That command's important because that's what's actually telling my build server or my local system that I want to use my container registry as my Helm chart repository. So if I'm using Helm, rather than going to stable or incubator / Nginx or Jenkins, instead I would do the name of my container registry / the name of my Helm chart. And I'm able to do that because I just add a repo. I like to always double check my work, so I use Helm search to search that the chart actually exists, and it should find it in my repo. And then the last one is Helm install, where I use my registry and the name of the chart. And we'll see that live. So here's a way that containers, now that we make sure we have a full understanding of containers works, let's go back to DevOps. Because what's ultimately going to make you a superhero isn't understanding every single thing there is to know about containers. But it is understanding the foundation and the basics for how containers works. How many people in the room watch The Flash? TV show, DC. Okay, so like, I don't know, 10 of you. So in The Flash, it's about this guy who can run super fast named Barry Allen. And in the first season, compared to the 6th season, if you notice, they're talking a lot about science in the first season. Barry's learning the science of running up buildings and how to spin his arms really fast to create vacuums. He's talking about the foundation. By the 6th season, he's progressed a lot as a superhero because he has that firm foundation. So what's actually going to supercharge your DevOps and container workflow is how you approach it. You'll notice in the demo that the DevOps practices don't actually change, regardless of where I'm deploying it. Whether I'm deploying it to Azure App Service, Azure Kubernetes Service, Google, whatever the endpoint is, the tasks aren't going to change because we understand the foundation. So as that just crashed, of course, with PowerPoint. Gotta love that. Normally I have a second computer up here and running, but that's okay. So it's restarting. We'll go ahead and get this up and running real quick. And this is how fast can I fail over live on stage. All right. So you'll notice in this, I have my little human. Maybe I'm using Azure, maybe I'm using VS Code to actually edit my tasks. I push stuff over to GitHub. I have some sort of build server. You can take out this icon and replace it with Jenkins or Travis or any CI/CD system. It connects over to AZACR. I have Kubernetes. Maybe I have a database. I use Azure Monitor to monitor this. Maybe I import stuff over into Grafana to get data. But this is a standard flow for containers with DevOps. The tasks that you use are the same tasks I would use locally. Now that I understand how containers work, how I build containers, later on tonight we're going to go deeper into how to build Helm charts, but I understand how Kubernetes works with declarative syntax and YAML. Now I can do something a little bit more creative because a lot of people maybe they aren't using Azure DevOps. Maybe they're still using Jenkins for how they're building stuff. So in the demo, I actually have a GitHub repo that's connected over to a Jenkins build server. It's going to push over to Azure Container Registry. Once it pushes to Azure Container Registry, it's going to go over to Azure DevOps Release, which is where I have my release pipeline, and simultaneously, it'll deploy out to Dev, QA, and Prod with Azure Web App and Azure Kubernetes Service. And I'm going to show you how easy it was to get that set up. So the first thing I'm going to do is show the demo slide because that animation was cool. The next thing I'm going to do is switch over to Chrome here. Now, hopefully, we can zoom in here if we need to, but hopefully you can see this where you can see the change. I can even drill down right here where I click on this. You can see all checks have passed. This was my Jenkins build. This is the only build that I have set up. Azure DevOps isn't reporting to this because it's not connected from a build perspective. But here is my deployment. I had it go through and test. I am using Helm, so it packaged things up. It uploaded Helm to Azure Container Registry. I had it do Docker build. We talked about the importance of security in containers. I'm using a security scanning tool called Aqua, which scans the layers of my containers as well as enforces policy. And then I ultimately publish my container over to Azure Container Registry. But a better visualization of what's actually happening is the classic look, not just the pretty one that always looks green. And if I drill down into Aqua Security Scanner, I can see the security logs that the image is allowed, which is why it got pushed over to my Azure DevOps. I can even drill down into my vulnerabilities and my layers itself to see what problems actually exist. Now, if I drill back up, in the event that something had failed, I can go to a previous build where it didn't meet my corporate policy, and I can see that the image is non-compliant. And in this instance, I was running a Docker image that was trying to run a super user, but I set a policy saying don't run it. Now, the neat thing about this demo is I'm actually using third-party services. The only two Microsoft products I'm using is Azure Kubernetes Service and Azure DevOps. I'm using third-party integration to still accomplish the same tasks. And you'll notice the tasks don't change. I'm still going to build code, I'm still going to push code, and I'm going to package it up and deploy. So when I go over to if I were to use Azure DevOps for those same tasks, which was running Helm, packaging it up, building, running a security scan, I have those same tasks right here in Azure DevOps. And I could just go in and add, all this is and all a pipeline is just a task runner. We'll zoom out here real quick so you can see. I have something called the marketplace on the right-hand side. I can go in and search for whatever tasks I want for whatever thing I'm trying to do. And there I have Helm. We even have, if you're using AWS, there's AWS in there, there's Cloud Foundry, there's so many different ones. But that's how I would define that particular build. But I told you I was going to talk about a release pipeline. So I have a release pipeline that I created, which I actually want to show you, I think, yep, this slide, or this tab. So this artifact, the second it hits my Azure Container Registry, I have a continuous deployment trigger set up. All I had to do was go in and say, add, and I can choose different artifact types to fire that off. In fact, I have 9 different ones. I could link this over to Jenkins, but that doesn't work with a Jenkins file or a Jenkins pipeline itself. So instead, I had Azure Container Registry be my trigger. I choose my service connection, which is just my authentication to my Azure subscription. And from there, I would choose the resource group, and I would choose the Azure Container Registry and repository information, which is all I did for this particular artifact. Then I have 2 different stages, and I can add this stage by simply clicking Add over here, and I choose New Stage. Now, the second I choose a stage, I'm also given the similar thing that you saw in Build, where I can choose a template. So if I wanted to deploy to App Service, I choose the App Service template, or maybe I want Helm, so I'll go ahead and search for the Helm template, and I would just choose those accordingly. Now, you'll notice something. I already have it set up, but I have my AKS tasks, and these are just task runners. So what am I doing to get it out onto Kubernetes? If I'm using Helm, I have to make sure Helm's on the system. So I install Helm. I run Helm init to set up the connection between Helm and Kubernetes. But then I run this Azure CLI command. And I'm going to zoom in here. We're going to scroll over. Now you'll notice AZACR Helm repo add. That's the same command I showed you on the slide that added the Helm repo, so I can use that on my next deployment step. So you'll see that right here under Helm upgrade. I scroll down, and my actual chart name is JDK8's Spring Music, because that's the name of my registry. Now, if I scroll out, I can set my values and everything accordingly. You'll notice my release name is BB Music Dev. Now, I can change that because I have dev, QA, and prod, and I'm just selecting the different stages here, but I want to show you how easy it was to get that started. Once I had my task set up with whatever variables, all I had to do, I'm going to go to the end here, all I had to do was hit clone, and that's just going to copy that task. In fact, you can see right here where I already cloned the production one for AKS. I cloned that. It's going to save all those tasks. So now I can go in and I make changes to whatever that environment is. A second production cluster, I just choose the parameters. I can do the same thing under Web App. So I have Azure App Service. This is where I talked about deployment slots. And I just choose the different slot. Let me zoom in. I just choose the different slot that it's going to. And again, this kind of helps visualize how simple or complex things can become. and definitely evaluate if you should use Kubernetes or AKS, or Kubernetes or Azure Web Apps. But the one thing I want to point out is the artifact. What I built from Jenkins, even though I built Helm charts and everything, didn't matter, because the artifact was just the Docker image itself. So I can take that container and I can put it anywhere. That's the most important thing to remember with becoming a DevOps superhero, is that the tasks don't change around it. I can take this and I can scale. I can make it simple or I can make it complex, but once I have the infrastructure and the foundation in place, then I can take it and go as far as I need to. So we'll go ahead and wrap up here, switch back over to PowerPoint. One thing that I didn't get to dive too deep into, but I have a slide for that. I'm going to play from current slide. Is the other thing I can do in my releases is I can set things like deployment approvals and gates. So you'll notice in both AKS and Web App, and it's just clicking on the little human person right there, and it just chooses what kind of policies you want. Maybe I want the person who requests the change not to be the person who approves the change, but that you need to have an approval both at the end of deployment and at the beginning of deploying into the next environment. Maybe dev is done, but QA is still working on their sprint, so I don't want it to flow right through. And I can also automate things a little bit further. You'll notice the right-hand side is doing something called processing gates. And so that's where I'm actually setting up some logic to evaluate whether or not that should flow through. Maybe the application worked in QA, both in Azure Web App and in AKS. But what happens if there's actually errors or exceptions? I can set up alerts in Azure and have it query those alerts and actually either fail the build and not let it through the gate. It's like Lord of the Rings, you cannot pass. That's essentially what the gates are doing. Or I can have it trigger a REST API. I can have it trigger a function. There's so many different things I can do, and I do that just from clicking that little icon and defining the parameters accordingly. So at the end of the day, the secret to really becoming a container superhero is KISS. Now, in the States, we have a band called KISS. That's not this kind of KISS. We also have a saying where KISS kind of is name calling. Shame on you for thinking that. But what I think is KISS means keep it super simple. You don't have to overcomplicate it. In fact, the pipeline that I wrote in Jenkins, while it looks complicated, for this application, I copy and pasted it from another project because I have a library that I imported for all those tasks. I have a blog post that's going live about that next week. But I only changed 2 lines of code, and that was the name of the application. So I kept everything in something that I could repeat and recycle it. Keep it as simple as possible. Again, to quote Agents of S.H.I.E.L.D., the steps you take don't have to be big. They just have to lead you in the right direction. Gemma Simmons. You don't have to go super complicated or do Kubernetes just because it's the coolest thing to do. And I think that's what I really try to get to at the root of these kinds of sessions, is so many people say, how do I just want to do everything, all the things with Kubernetes, all the deployments. But why? Especially for an application like I did in my demo, Kubernetes wouldn't be the right solution for that. Azure Web Apps was so much simpler to set up, and the build pipeline would have been 3 less steps. But it would have still gotten me in the same direction at the same place. And because I had the container already built and the infrastructure in place, if I wanted to, if business demands ever called for it, I could scale and still deploy it out into a Kubernetes service. Key questions you can ask yourself: what are my main objectives? What am I really trying to do to deliver value? How can I gauge? What are my indicators for those objectives? How do I know if I'm meeting those? And a really important question to ask yourself is ask yourself, does this add value? Or does this add unnecessary complexity? Is this going to make it more challenging? Because sometimes all it takes to be a hero at the end of the day is asking, why are we doing this? Maybe we could do it like this. Oh, that's so simple. Thank you so much. You saved the day. Sometimes that's the answer. And most importantly, to end on a little bit of humor, remember, it's just a waffle. It's just a delivery system at the end of the day. Everything else around it is fluff and strawberries and everything else, but it's just a waffle. Finally, here's a picture of me and little information about what I do. I love technology and community, and frankly, that's why I am here. The heart of everything, I am an engineer, so I love getting to hang out and spend time with other engineers like all of you. I tend to focus heavily on Linux, open source software, DevOps, and containers. If you follow me online, I do post a lot of stuff about Disney, Marvel, now that Disney owns Marvel, fitness. And you can find me online at Twitter, Instagram, and GitHub. No relation to James Deen, which means there's 2 E's in my last name. And finally, this is the slide that everyone wants. Scan me, here's a present for you. This has everything that I demoed, including links to the pipeline that I used for Jenkins if you're already more advanced. Helm charts, everything is on this repo. I know that text is really small. DevOps Days Monovideo was a very long word, but that says aka.ms/JL Deen, Deen, /DevOps Days Montevideo. And then, thank you very much.